Hello everyone, welcome to Exemplar Physics where we study concepts by solving questions. In this video, I have taken questions from NCERT Exemplar and from the topic magnetic effects of electric current. Previously also, I have made some videos on the same topic, the link to which will be given in the description section, as well as I have made a playlist for you. So I hope you will like this video too. So let's jump into the video. Let's see the first question. First question is, if the key in the arrangement, you can see the figure, is taken out, that is the circuit is made open, and the magnetic field lines are drawn over the horizontal plane ABCD, the lines are, the options are A. Concentric circles, B. Elliptical in shape, C. Straight lines parallel to each other, D. Concentric circles near the point O, but the elliptical shapes as we go away from it. So for this, let us understand the concept over here. Here we have a battery source. As per convention, the current will travel from the positive end of the battery, that is this one, to negative end of the battery through the circuit. So if we follow this path, as we consider the current carrying conductor, which enters the plane ABCD, so the current will be going into the plane. Now you may know that the magnetic field lines around the current carrying conductor, straight current carrying conductor, will be concentric circles with center as the conductor. And how do you get this? With the help of a compass, placing the compass at every point and noting the north of the compass. If you join all those points, the locus becomes a concentric circle. So on this board, the magnetic field lines will be concentric circles. Now, how to get the direction of concentric circles? The north pole of the compass will give you the direction at a given specific point on the concentric circle. Since we are not using the compass over here, you can also use Maxwell's right hand thumb rule. So what is this rule? This rule says that if you keep your right hand and stretch your thumb in the direction of electric current, then circle fingers will give you the direction of magnetic field. Then circle fingers will give you the direction of magnetic field. So if you keep your right hand in such a way that the thumb is in the direction of magnetic field lines, then the circle fingers of your right hand. So I'm going to try drawing that over here. So the circle fingers of your right hand will give you the direction of the magnetic field. So please try with your own hand. So the direction will be like this. This is the direction of magnetic field lines over here. It's going to be like this. So this is the concept, and now let's jump into the question. So the question says that if the key in the arrangement is taken out, so the key is taken out, that means the circuit is open. So how much the current will be flowing through the circuit? So current becomes 0. And the magnetic field lines are drawn over the horizontal plane ABCD. Now, how do you draw the magnetic field lines? You are going to draw the magnetic field lines using the compass. Now, since there is no magnetic field because no current is flowing through the conductor, therefore the compass will interact with the magnetic field of the earth. It is going to show the only one direction, that is the north direction. So how are the magnetic field lines going to be on the sheet? So or wherever you place it, the compass is going to show you the geographical north. Hence all the magnetic field lines will be parallel to each other and will be straight lines. So the answer to the question is straight lines parallel to each other. Remember, when is that? When the key is taken out. Now let's go to the next question. The next question is, so what do we have here? The circular loop is placed in the plane perpendicular to the paper. So this loop is being placed perpendicular to the paper. So you have to imagine a plane over here. So 3D imagination is required. So you have to imagine as a paper over here, and the loop is kept on the paper. So some part of the loop will be out of the paper and some part is going to be inside the paper. So which will not be visible to us. To give you an effect, I'm going to shade it to give you the effect. So you will be only seeing the upper part of the loop. So this lower part will not be visible to you. So this is how the plane is. So this is not going to be visible to you. Down lower part, you will be able to see only upper part. So that's what the question says. So you have a plane over there. The current as seen from point A and B in the plane of paper on the axis of the coil. So the current is seen from point A. It is anti-clockwise direction. When the current is seen from point A, where is point A? Here is your point A. When it is seen from there, it is anti-clockwise direction. And when it is seen from B side, it is clockwise respectively. The magnetic field lines point from B to A. So the magnetic field lines are pointing from B towards A. So this is the direction of magnetic field lines, B to A. This is how you have the magnetic field lines. I hope there is not too much clumsy. Let us rub and just draw magnetic field lines. So magnetic field lines are, the direction of the magnetic field lines are from A. So magnetic field lines enter from B towards A. So the magnetic field lines look somewhat like this. This is the direction of magnetic field lines. The magnetic field lines point from B to A. The north pole of the magnet is on the face close to. So north pole of this magnet, which is a resultant of the current flowing through the circular loop, will be which side? So to understand this, you have to understand how the magnetic field lines move in a solenoid or bar magnet. So first let me show you for a solenoid. In the solenoid, if you see in this figure, the magnetic field lines are coming out from one end. So this is the direction in which the magnetic field lines are coming out. So if you compare it with the bar magnet, in the bar magnet, through which end the magnetic field lines are coming out? That is your north. Hence, the end where the magnetic field lines are coming out is the north pole. Now let's see the other end in which the magnetic field lines are coming into the solenoid. This is the end through which the magnetic field lines are coming into the solenoid. Hence, if you compare it with the bar magnet, magnetic field lines coming into the solenoid will act as south pole. So a solenoid acts like a bar magnet which is made up of many number of turns. Here we have just one turn or one loop. Hence the end where the magnetic field lines are coming out is going to be the north pole. That means the end A is going to be the north pole, and the magnetic field lines entering into the loop, that is where the magnetic field lines are entering, will be called as south pole. So if the magnetic field lines are coming out, that end is going to be north pole, and if the magnetic field lines are entering, that is going to be a south pole. I hope this will be useful in answering this question. the north pole of the resultant magnet is on the face close to. So north pole is close to. The answer is option A. So that's the answer to this question. And in order to remember, I'll give you a tip for this question. So let us look at this question in another way. Here, a circular loop is given to us, and the current in the direction of the current is also given to us. So let us draw the loops over here. So I'm going to draw one loop over here and another circular loop over here. So two loops are there. Now, how many directions are possible? The question says the current is as seen from point A and B is anti-clockwise and clockwise respectively. So it doesn't matter. If we have two loops, the directions of the current can only be in two directions. One is clockwise according to the hands of the clock, and the other one is anti-clockwise, which is opposite to the direction of hands of the clock. So there could be only two directions possible over here. The one is clockwise, the other one is anti-clockwise. So understand the concept. What we do is we write S inside the both the loops. And to the ends of the S, let us put arrows. The ends of S, let us put arrows. Now you please check the arrows of or the direction of the current with the direction of the arrows on S. If they both coincide, then that is going to be the south pole. If they both do not coincide, that is in opposite orientation, then it is going to be north pole. So in the question says at point A, it is anti-clockwise direction. So what direction is this? Current is moving in anti-clockwise direction. So anti-clockwise direction leads to north pole. So A is going to be the north pole, and the other one, that is here B. From B, it looks as if it is in clockwise direction. So this is your clockwise direction. So clockwise direction leads to south pole. So B is going to act as south pole. So even if the direction of magnetic field lines are not given, only the direction of current through the circular loop is given, you can tell whether it acts as a north pole or south pole with the help of this simple trick. So I hope you have understood the concept. We have taken two good questions over here. And if you still have any doubt in these two questions or any other questions, you can write it in the comment section, or you can join our Telegram channel, whose link is given in the description section. So if you have enjoyed watching it and learned something new, please like this video, subscribe to the channel, and share it with your friends and family members. Thanks for watching. We'll meet again with another video.